Assalamualaikum warahmatullahi wabarakatuh. I am from Group 4, Session 3. I would like to present about the transfer function, which is third order. Here is my group members. The first one is Nani Izzati, Ahmad Fidaus, Nick Muhammad Aizat, and me, Muhammad Ahmad Arif. So from my part is introduction. Transfer function is a convenient way to represent a linear time in variance system in terms of input-output relationship. Transfer function also are frequency used in block diagram representation of system and are popular for performing time domain and frequency domain analysis and control design. The key advantage of transfer function is that they allow engineers to use simple algebraic equation instead of complex differential equation for applying and designing system. Next, for the introduction of P, PI and PID controllers, which is P, PI and PID controller this project is to compare the performance of various controllers such as the proportional controller P, proportional integral controller PI, and proportional integral derivative controller PID controller, and how they affect the performance. Also explain how each controller has its own set of parameters as well as features like response time and setting time for all controllers. Next, the objective of this assignment is we need to analyze the open loop system and closed loop system response under different controller, which such as P, PI and also PID controllers. The second one is to obtain parameter of different controller using Ziegler-Nichols first method using MATLAB.
For part method, loop tuner. Tuning the control loop is setting the control parameter to its optimal value for obtain the desired control response. For the tuning method, they have a few methods where manual tuning method, Ziegler-Nichols tuning method, Chu-Chun tuning method. And they have several difference between Ziegler-Nichols and Chu-Chun, where this is the compare the two methods. First, Ziegler can use for any arrangement system, but for Chu-Chun can be only used for the first order system. For Ziegler, they are more widely used, and for Chu-Chun, they are more flexible for the first order system. And Ziegler applies when the dead time is less than of the time constant. For Chu-Chun, it can be accept up to this value and it can be extended. That's all. Thank you.
Hi, Assalamualaikum. My name is Nani Izzati binti Kahar. My metric number C20029. So today I'm going to present about simulation third order transfer function. For this simulation equation, I just pick a random number 1/6s power of 3 plus 10s power of 2 plus 6s plus 2. This is the equation for third order transfer function. First, we need to define STF, it means transfer function. And for open loop system, figure 1 is open loop system here. So from this figure, we can define K, L and T. For K, here is K, the average the average graph, and then for L 0.41, from 0 to 0.5, the amplitude 0.4 is the graph when it want to increase. And then for T 5.99 is at the time 5.99 here when the graph at the higher point. 5199 second. And then we can find we can find A is equal K times L over T, Ti 2 times L over 2, and Td is L over 2. And then for find Kp, 1.2 over A, Ki is Kp over Ti, and Kd is Kp times Td. So this is the answer for K, L, and T. For Ti, 2 times L over 2 is 0.4100. For Td, L over 2 is 0.2050. For Ki, Kp over Ti, so Ki is 79.669. So for control system, PID, Kp, Ki, and Kd for closed loop, we use a Ziegler-Nichols method. So this is figure for my method of the transfer function closed loop. And then from this, we can define PID with PID Turner Simulink here. So for P, this is graph for P Turner, and this is graph for PI, and then the last one is graph for PID.
Assalamualaikum and hi, my name is Nik Muhammad Aizat bin Jaafar. My numeric is CE200044. So today I want to show you about the result and discussion our group assignment 2. So the method we use is Ziegler-Nichols method. So this is a third order transfer function. This coding we use MATLAB to run, and for the PID, we use Simulink to show to find the P, PI, and PID type. So this is open loop. We use this value to the step. So for this figure to show the waveform step. And then when we run this coding, this is appear at the result coding. So this this formula with Kp 32.7 and Ki 79.7 and Kd 6.7. So this is continuous time PID control in parallel form. So when we run that, this waveform will appear. This is the step response figure we got when they run the coding at the MATLAB. So the PID Turner closed loop. This is a closed loop step response for P. So we just press this type to find the change the P, PI, and PID. So for the parameter P, we just got the Kp tune, and the value is 1.9687. And for the closed loop step response for PI, we got just Kp and Ki. So for the tune is 0.3348 for Ki, 0.42827. So for Kd and Tf is unknown. For the closed loop step response for PID, for the last is the parameter for PID we got is Kp 0.49175, DTI we got 0.42771, and KD we got 0.14135. And for DTF for PID is unknown. And this is all from me. Thank you.
Assalamu alaikum, Doctor. My name is Mahal Abdurrahman Ahmed. My matrix number is PE 190022. Today I'm going to present the conclusion of the assignment. First, the method begins by setting the integral and derivative gains to zero and increase the proportional gain until the system becomes unstable. The PID tuner, on the other hand, is the process of finding proportional, integral, and derivative gains values for a PID controller to get the required performance and meet your design needs. This eliminates the above-mentioned trial and error process. That is automatic PID adjustment. Finally, with automatic PID tuning, you can use PID tune to access the tuning algorithm directly, or you can access the tuning algorithm through a good graphical user interface with a PID tuner. Thank you, Doctor.